All right, if we look at 17, it says a large sample, 98% confidence interval for the proportion of hotel reservations that are canceled on the intended arrival day is 0.048 to 0.112. What is the point estimate for the proportion of hotel reservations that are canceled on the intended arrival day from which this interval was constructed? So the key to this is understanding that the point estimate is the median or the middle of your interval. So to find the median of your interval, all we're going to do is we're going to take the upper bound, 0.112, and we are going to add the lower bound, 0.048, and we are just going to divide that by 2. All right, and once we divide it by 2, we do end up with, which I already clicked it, but it is going to be 0.080, so our answer will be C. All right, big takeaway for this question is the point estimate is the middle, it's the median of your confidence interval. All right, now if we look at question 18, when using a one-sample T procedure to construct a confidence interval for the mean of a finite population, a condition is that the population size be at least 10 times the sample size. The reason for this condition is to ensure that, right, and this is going to be that the degree of dependence among observations is negligible. All right, so this is our 10% condition. Okay, the sample size is large enough. That is what we use for our large counts, and that's to check to see if it's approximately normal. The central limit theorem, that is going to be, the central limit theorem is applicable for the sample mean. All right, that's the same idea as A. So the central limit theorem is where we get our sample size is large enough. Okay, when we're talking about population means, it's that the sample size is at least 30. Okay, the sample standard deviation is a good approximation of the population standard deviation. That one might get you because our 10% condition is what we check when we calculate standard deviation. But the key here is when we check the 10% condition, it's because we're looking for independence. All right, so our 10% condition is when we can't say that they're independent, we check our 10% condition. All right, and that's why D is the correct answer. The degree of dependence among observations is negligible. All right, the sampling method is not biased. The 10% condition has nothing to do with bias. For 19, a nonprofit organization plans to hold a raffle to raise funds for its operations. A total of 1,000 raffle tickets will be sold for $1 each. After all tickets are sold, one ticket will be selected at random and its owner will receive $50. The expected value for the net gain for each ticket is 95 cents. What is the meaning of the expected value in this context? All right, so the expected value in this specific situation is for each raffle ticket, right? If you were to buy one raffle ticket, each raffle ticket, an owner will lose 95 cents on average. So if we look at our answer choices for 19, our best answer choice is going to be B, which the ticket owners lose an average of 95 cents per raffle ticket. If we look at 20, suppose that on a hypothesis test for a single population mean, the alternative hypothesis is that the population mean is less than 10. Assume that the alternative is true. For a fixed sample size and significance level alpha, the power of the test will be greatest if the actual mean for which of the following. So remember that when we are trying to solve for this, right? If we are trying to, if the alternative is true, then we want to reject the null hypothesis, all right? So the value that makes this more true, all right, is going to give us a higher power of the test. The power of the test is the ability to correctly reject the null, all right? So if we look at this and we're testing to see if the mean is less than 10, well, if we look at all of our answer choices, A is going to be the correct answer because 8 is the furthest away from 10 while also being less than 10. right? You could argue that 13 is further from 10 than 8. That's true, but it is greater. And remember, the alternative is that the mean is less than 10. So for this one, our answer is going to be 8. All right, if we look at question 21, it says the residual plots from 5 different least squared regression lines are shown below. Which of the plots provides the strongest evidence that its regression line is an appropriate model for the data and is consistent with the assumptions required for inference for regression? All right, so for this one, right, remember that when we are looking at a residual plot, right, we want to see no patterns in the residuals, right? And if we see no pattern in the residual, that means the linear model is appropriate. So if we look at A and B, both of those clearly have a shape and pattern to them. All right, A almost looks parabolic. All right, B almost looks kind of absolute value-ish. All right, C, D, and E are our next possible options. And if we had to pick the one that has no patterns, all right, and no patterns or no obvious shapes, for that, this one, our answer is going to be C. All right, once again, that one's just kind of scattered. There's no shape to it. There's no real pattern. The points are just kind of all there. Now 22 says a random sample of 50 students at a large high school resulted in a 95% confidence interval for the mean number of hours of sleep per day, okay, of 6.73 hours to 7.67 hours. Which of the following statement best summarizes the meaning of this confidence interval? All right, if we look at option A, it says about 95% of all random samples of 50 students from this population would result in a 95% confidence interval of 6.73 to 7.67. This is incorrect because we will not get that same interval each time. Okay, we are going to, when we build the confidence interval, if we were to use the same method over and over and over again, what the confidence interval is doing is capturing, right, the true mean for the average number or the average hour of sleep for students at this school, right? And using this method, we would capture that true mean 95% of the time. Right, so A is not going to be the correct answer. B, about 95% of all random samples of 50 students from this population would result in a 95% confidence interval that covered the population mean number of hours of sleep per day. That's going to be our correct answer. Our answer is going to be B. Now, if we were to look at 23, okay, 23 says a local company is interested in supplying environmentally friendly initiatives such as carpooling among employees. The company surveyed all of the 200 employees at the downtown offices. Employees responded as to whether or not they own a car and to the location of the home where they live. The results are shown in the table below. Which of the following statement about a randomly chosen person from these 200 employees is true? So if we go through these, A says if the person owns a car, he or she is more likely to live elsewhere in the city than to live in the downtown area city. So this is a conditional probability. So what it's saying is I want to find the probability. Okay, the condition is that the person owns a car, and they're saying that they're more likely to live elsewhere. So I'm going to go, they live elsewhere, given they own a car. And so if we were to solve this, all right, we're going to end up with a probability of, if we look at they live elsewhere and they own a car, all right, that's going to be 15. So we're going to have 15 over. And then remember, now we just divide this by the probability that they own a car. So if we look at this whole entire row of everybody that owns a car, all in all, there's 60 of them. So that's going to be 15 over 60. And now we have to compare this to the probability that they live downtown. I'm going to abbreviate downtown, given they own a car. And so the probability that they live downtown and own a car, that's going to be this one right here. That's going to be 10 over the probability that they own a car, which once again, there's 60 employees who own a car. And if we compare 15 over 60 is greater than 10 over 60. So in this case, A is going to be correct. All right, remember conditional probability, the general form, if we have the probability of A given B. All right, how we solve that is we take the probability of A and B, and we divide it by the probability of B. We kind of lucked out on that one because A happens to be our answer. If A was false, then we would go to B and we would do the same thing. If the person does not own a car, he or she is more likely to live outside of the city. So we would say the probability they live outside given they don't own a car, and we would compare that to the probability they live in the city, okay, given they don't own a car. And we'd have to just check all of these to see which one is true. But like I said, we lucked out. A was true for us. All right, if we look at 24, it says a random sample of 432 voters revealed that 100 are in favor of a certain bond issue. A 95% confidence interval for the proportion of the population of voters who are in favor of the bond issue is. And so this one is just remembering the formatting. How do we create a confidence interval? We take our stat, plus and minus the critical value, times our standard error. I'm going to abbreviate standard error. All right, in this case, our stat we know is that they said out of 432 voters, 100 of them. So we have 100 over 432, plus and minus. And now to find our critical value, we can do that two ways. I'm going to show you the calculator way. So we can go to stats, we can go to distributions, and we can do inverse norm. We can use the area of the tail. If it's a 95% confidence interval, then that means we have 5% outside of my confidence interval, which means we have 2.5% as a single tail. So I can type in 0.025. Right? My mean is 0. My standard deviation is 1. I'm going to go ahead and say OK. And it shows me my critical value of 1.96 is what we can round that to. Now, I also showed you earlier in one of my past videos that you could use the t-distribution, right? And you could go down to at the very bottom of your table, of your chart, on the t-distribution, you could go down to the confidence levels, and you could go to 95%, and right above that 95% is going to give you the critical value, your z-star, which would read 1.96 as well. But I wanted to show you both methods, calculator and your chart. Right, so we know that this is going to be 1.96. All right, and now we can go ahead and multiply this by the standard error. The standard error for proportions is p hat times 1 minus p hat divided by n. So if we went ahead and actually did this 100 over 432, we would see that that's going to give us a decimal of 0.231. So my p hat is going to be 0.231 times 1 minus 0.231, and that's going to give me 0.769. And I divide that by my sample size, which was 432. All right, so now I've got to go ahead and look at these and see which of these A through E is the correct answer. And if I compare, my answer is going to be D. Now, if we look at question 25, the commuting time for a student to travel from home to a college campus is a normal distribution with a mean of 30 minutes and a standard deviation of 5 minutes. If the student leaves home at 8:25 a.m., what is the probability that the student will arrive at the college campus later than 9 a.m.? I went ahead and sketched this out. If he leaves at 8:25 and we're looking to see if he arrives on campus later than 9 a.m., then that means it took him more than 35 minutes to get to campus. So we want to find the probability that the travel time is greater than 35 minutes. We're going to go ahead and use normal CDF for this. My lower bound is going to be 35. My upper bound is going to be infinity, or I just went ahead and did 99999. All right, my mean is 30, and my standard deviation is 5. I'm going to hit OK, and that gives me my answer of 0.1586, or we would say option A, which is a 16% chance.